get into recording. I'm recording. Let's get into learning how to name our complex ions and coordination compounds, okay? So these are some of the most commonly occurring Lewis bases that act as ligands. So remember, a ligand in a complex ion is a Lewis base because it donates its electron pairs to the central metal atom. And what you can see, what all of these have in common is they all have lone pairs to give. So let's write that, lone pairs to give, okay? So this is the list of complex ions that I want you to know for this class. And I do want you to know the names of these. Most of these names you already know as the ligand name, which is just like the base chemical name that you learned in Chem 109. And then the name gets changed ever so slightly when it becomes a complex ion. So for example, if we have any of the halogens, iodide, bromide, chloride, or fluoride, those are all excellent Lewis bases, which means they make good ligands, okay? And when we put the name in a complex ion, you notice how it changes. Iodide becomes iodo, bromide becomes bromo. You can now say, what's up, bromo? Chloride becomes chloro, and fluoride becomes fluoro. So that's a very minor shift for you to recognize. And of course, they're all -1 charged. And we're going to flesh this out in more detail soon, but this number of donor groups, that means that it only forms one coordinate bond per ligand. So you're not going to see iodine, like one individual iodine, make 2 bonds, right? It's only going to make 1 bond, okay? So now nitrite, which we remember is NO2 minus. That makes a good ligand, and we call that nitro. Hydroxide, we know hydroxide really well now, OH minus. When that occurs as a ligand, it's hydroxo. So hopefully you can see this scheme that's going. So water is kind of the weird one. It becomes aqua. And hopefully that's not too difficult to remember because we use aqua quite a bit to refer to water. So ammonia, right, is NH3, that becomes amine, okay, and we've heard that term before. So this one is a little bit more complicated. The ethylene diamine is this complex ion right here. And so the name within the complex ion is the same, so we would just call it ethylene diamine. And the way that we can kind of break this down is if you notice, there's a diamine, that means 2 amines, and there they are, NH2, NH2, okay? And it's not NH3 because remember, one of those hydrogens is now replaced by this carbon bond, okay? And ethylene, ethyl means 2 carbons, so ethylene diamine. And this is neutral, and I forgot to mention this, right? Water, ammonia, and ethylene diamine are all neutral in ligands, so they don't add a charge. But now we notice that ethylene diamine has 2 donor groups, so we're going to see how that manifests soon. So we talked about cyanide, Cn minus, and that becomes cyano. Carbon monoxide, we know, CO, that becomes carbonyl. And then the last one I want you to know is the thiocyanate. And so that name is the same, and this is SCN, okay? So I want you to know this list, make flashcards if you have to, and just recognize the name change is very slight.